Okay, part 2 of final review. Let's get started. So, draw a triangular prism. Now, we're going to really talk about what this is when we get the 3D shape, so don't worry too much about that. That wouldn't show up on a test or a quiz right now. But a triangular prism just means a triangle pulled orthogonally or perpendicularly through space. So we draw it just by putting another copy of that same triangle somewhere else in space. And then we just connect all the corresponding vertices. And then we just use dashed lines to say what's in the back. So I'm going to use dashed lines to say this one back here is dashed, and this one is dashed, and this one is dashed. And now it says label the parallel planes ABC. Well, there's only 2 parallel planes here, right? Because every single set of planes in this picture is intersecting except for this plane and this plane. So it's saying label these 2 as A, B, C, D. So we label a plane with 3 non-collinear points. That's the same way we determine a plane. So it just means label one of these A, B, C and the other one D, E, F. Okay, so I'm going to go ahead and erase that pink there. All right, there we go. Identify 2 planes in your triangular prism that intersect and name their intersection. So any 2 planes other than the 2 we just described, planes A, B, C, and planes D, E, F. So let's just pick any 3 points that are non-collinear. I'm going to pick, I don't know, let's go plane ADC, okay? And so I'll highlight this on the picture to show you plane ADC. And then I'll highlight on the picture to show you plane, and we'll do the flat one on the bottom there. So plane, now I could choose any of B, C, E, or F to talk about the bottom one. So I'll just pick any of the letters there. So I'll do BCE. Okay, so we got plane BCE and plane ADC. So that's the intersection of this side-facing plane right here. And then the plane laying flat here. Well, those 2 planes intersect, right? Any 2 planes that aren't parallel will intersect to form a line. Just think of this crease in a book, right? You hinge it open and close, but it intersects in that line that is the seam of the book. And so where they intersect is exactly this line, right? The flat plane here and the sideways plane here meet at this edge. And so that would be line CF would be their intersection. Perfect, okay. I'm going to go ahead and erase that pink here in the picture just to leave it as it was. All right, so now it says name 2 lines in your triangular prism that are skew. Remember, skew just means that so lines can either be intersecting, where they cross at a point, or they can be parallel, or they can be neither of those 2 things, which is only possible in 3D. In 2D, every line is one of those 2. But in 3D, you can have 2 lines that are skew, which means they're not parallel and they're not intersecting. So an example of this, I'll do it in, I don't know, purple here. Let's say CF, since we're already using that line here. And now if we pick like AC, that's going to hit that line at C. If we pick DF, that's going to hit that line at F. If we picked AD, it's going to be parallel to CF. If we pick BE, that's going to be parallel. But if we pick AB, AB is not going to hit C, and it's not going to be parallel. So that's skew. So we're going to pick lines AB and lines CF. Now, there are lots of combinations here. The key is that they are not intersecting and that they are not parallel. All right, identify each pair of angles as alternate interior, alternate exterior, corresponding, or consecutive interior. So the big idea here is if I'm given 2 angles, so angle 9 and angle 12, I'm looking at 2 angles at different intersections along the same transversal. So I know the transversal goes through those 2 intersections, and that's intersecting 2 lines. And so the 2 lines it's intersecting is this line and this line. So in regard to those 2 lines, like here's one intersection, here's the other, then how do those relate? Well, they're both the bottom left side. So if they're both in the same position along the transversal, those are corresponding angles, okay? Now, are they congruent? We exactly know they are not, because if the lines are parallel, they're congruent, or vice versa. If they're congruent, then lines are parallel. But these 2 lines visually are shown to intersect, so we know they're not parallel. So then we know they're not congruent angles. So anyways, let's jump into the next one then. So angle 2 and 3. So 2 and 3 here are along this transversal. That means the two lines they cross are this line and this line. So with regard to those two lines, these intersections, that's a consecutive interior or same side interior where we're hoping to make that 180-degree turn to get parallel lines. Again, the lines aren't parallel. So these are consecutive interior, or it could be same side interior depending on what book you're using. All right, and then 4 and 11. Let's look at 4 and 11. So again, 4 is here and 11 is here. So that's along this transversal. That means the two lines that transversal is crossing is this line and this line. So with regards to those, these two are on alternate sides of the transversal, and they're both exterior to the blue lines. So these are alternate, I'm just going to abbreviate, exterior angles. All right, and then number 7, hold on one second. It's saying if measure of 9 is 110, so here's 110, and measure of 8 is 30 degrees, so measure of 9 and measure of 8. That's an interesting question. And measure of angle 6, 9 and 8? How, what? Okay, sure. And measure of angle 6? We're looking for measure of angle 6. I think there was a typo here. I think they meant to tell us angle like 5, I'm guessing, because this is a triangle sums to 180. So I think that must have been a typo because 8 and 9 make a straight line. So these two should add up to 180. Those only add to 140. So that's just crazy town. Measure of angle 9 is 110. Yeah, that's a 9. And measure of angle 8 is 30. I mean, we're not missing anything. That's 9 and 30. So yeah, there must be a typo. We'll just say, oh, there's a different picture. Now I understand. Whew, that was confusing. I apologize. Okay, measure of angle 9 is right here. This is 110. Okay, measure of angle 8 is 30. Whew, I was like, that's impossible. Find measure of angle 6. So notice these are parallel, okay? So that's going to tell us that along this transversal, that this angle down here is 110. Okay, that's useful. All right, and then we also know 30. So what are we looking for? We're looking for 6, okay? Well, let's start filling in some other things too then. So we know all of these intersections up there. Now let's use the 8 and we'll say, oh, well, look at this. Along that transversal crossing these two parallel lines, corresponding angles are congruent. So if that's 30, that means this is 30 degrees right there. We also know, one more, if we have, I'll do it in a different color this time, if we have these two lines are parallel, that's shown right here, okay, then along this transversal, then corresponding angles are the same, so 110 means 110 is here, so 110, no, actually, that's not what we want to do. Let's erase that. We want to go the other direction, actually. We want to go from the top. So we want to say these two lines are parallel, crossing this transversal. So this one is 110 degrees, corresponding to 110. So same logic, just at a different place. And what we're going to use here is that triangle sum to 180. So if that one, now let's zoom in. We know that's 110. So this is 110, and this is 70, and this is 70. And over here, we got corresponding. So this was, I'm going to move the 12. This was 30 up here. So then we could do, that's 140 so far in this triangle. So that's left over for 40 degrees here. This was 30 degrees here. Another way to do it is say corresponding 70 to 70. Vertical angles was 30 to vertical angle 30. And so the leftover is 40. So any way you approached it, that was a kind of convoluted way. This is 40 degrees. Okay, so let's go back over here, 40 degrees. Now, 8 in this picture. So they actually give you that line in the middle. A lot of times we'll start with a problem like this, and then it's up to you to add that auxiliary parallel line right there, okay? Sorry, pause it there. I had a bunch of noise outside. So often we're given the picture like this, and it's up to us to add the auxiliary line. But here we're actually given the auxiliary line already. So we just have two sets of parallel lines. So this pair tells that this is a 180-degree turn, right? If parallel lines, then consecutive interior are supplementary. So one equation we can write is simply that 8x minus 7, whoa, that was crazy. So 8x minus 7 plus 3x minus 11 is equal to 180. And that means 11x minus 18 is 180. That means 11x equals 198, which x equals 18, because that's 10, yep, that's 11. So x equals 18. We could go back and plug it in just to double check. So that would be 18 times 8, that's 80 and 64, so that's 144 minus 7, that's 137 degrees for this angle here. And then here we plug in 18 3 times that, that's 30, 54 minus 11, that gives us 33. And sure enough, oh, wait, I did something wrong there, that's 43, there we go. And 43 and 137, when you add up, does give us 180. So that worked out. That's nice. Then let's try for y. So y, we have the bottom lines are parallel too. So that means that alternate interior angles are congruent. So that tells us that 2y plus 23 equals 4y plus 8. Okay, so subtracting the 8, we have 15. Subtracting the 2y, we get 2y. So y equals 7.5, or 15 halves. Plugging that in, we get, this is 30 plus 8, so this is 38 degrees here. And then up here we get 15 plus 23, that's also 38 degrees, great. And so now if we have a 38 degrees here, and this is supplementary, then we go, well, that means 3z squared minus 5 plus 38 adds up to 180 degrees. And the way we got that was, again, I know it's pretty messy in here, but we just plugged in the y value here and got that this was a 38 degrees in this angle right here. And this is a straight line. So to solve for z, we just do that. So at first we go, oh shoot, this is a quadratic. 3z squared plus 33 equals 180. So one strategy to solve this quadratic is move everything to one side. 3z squared minus 147 equals 0, and then factor it and go, oh, divide by 3, so that's z squared minus 49 equals, and then factor it, z plus 7 times z minus 7 equals 0, and then if two things multiply to make 0, then this one's 0, this one's 0, so you solve them. So that's one strategy. However, the reason we use that strategy is when we have two terms that we can't get by itself. So if we have something like, for example, 3x squared plus 5x plus 1 equals 5, then we have no way to get this by itself. If we put everything else to the other side, there's x's in the answer. If we try and isolate this one, and we put everything else to the other side, we have x squared. So when we have two different variable terms, like an x squared and x, or an x cubed and an x, that's when we use that plan. But here we can isolate the z squared. You could just move this over there and get 3z squared equals 147. Divide by 3, you get z squared equals 49. Square root both sides, and you can't forget a plus or minus. Z is plus or minus 7. Now we go back and check if both of those are valid answers. Let's plug it in. And sure enough, when we plug it in, both positive 7 squared and negative 7 squared give us a 3 times 49 minus 5, or a 147 minus 5, or a 142. And so both of them gave us a valid positive angle. So yeah, there's two answers. So sorry, x equals 18, y equals 7.5, and z equals both positive 7 is a valid answer and negative 7. That's what the plus or minus 7 there is standing for. Or you could write them separate, 7, 7. Determine the slope of the line containing these points. So you could either plot this and then graph it, or you could just go m equals the difference in y, so rise, over the difference in x, run. So I'm going to call this my point 1 and my point 2. So xy 1 and xy 2. So this would be 23 minus negative 7, so there's two negatives there, over, and then x2 is 12 minus negative 6. So minus a negative 7 becomes positive, minus a negative 6 becomes plus. So we get 30 over 18, which reduces to 15 over 9, which reduces to 5 over 3. So the slope of that line is 5 over 3. The second one, we do the exact same thing. And so I'm going to go, the slope is the second y value. I'm going to name them the exact same order as here. So the second y value, negative 2.5, minus a negative 0.25, over, and then a 4, minus a negative 2. So this is on top plus, and on bottom plus. So on top, we get negative 2.5 plus a positive. So that cancels out. We get negative 2.25. Over, and this is a 6. I'm going to multiply by 4 on top and bottom, so I don't have a decimal, because I know on top, really, this is 2 1/4 or 9/4. So when I multiply by 4, I get negative 9, over, and on bottom, 24. And then I'm going to divide by 3, so I get negative 3 over 8. Okay, negative 3 over 8. So just the slope formula there. Determine whether these lines are parallel, perpendicular, or neither. So it's pairing these two together, and it's pairing these two together, and we're just seeing how these slopes relate, right? Now, if the slopes are the same, like a over b and a over b, well, then they're parallel. And if they're opposite reciprocal, so we flip it over to b over a, and one of them is negative, doesn't matter which, and the other's positive, then that's perpendicular. So we have parallel, we have perpendicular. That's what we're looking for, okay? I'm going to erase all that, and let's do the work. All right, so we got to find the slope 4 times. I'm going to do the same order as before, so x1, y1, x2, y2. All right, so the slope for QV is 12 minus negative 8 over 5 minus negative 3. That's plus, 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 plus. That's 20 over 8, which reduces to 10 over 4, which reduces to 5 over 2. Okay, perfect. So we got that slope. Then we're also going to do the slope of RM, which is, I'm going to do same order. So 2 minus 1 over negative 5 minus negative 2.5. That becomes a plus. So on top we get a 1, and on bottom we get a negative 2.5. So I don't want a decimal. I want a simplified fraction. So I'm going to multiply by 2 on top and bottom, and we get 2 over negative 5. And look at that. We had a 5 over 2 and a negative 2/5. Another way to check is whatever answers you get, you could always check if the two slopes multiply to make negative 1, because a over b times negative b over a, if you flip it negative, always they're going to cancel because you flipped it. And they were opposite signs. One was positive, one was negative, so it'll always be equal to negative 1. That's just a quick way to check if they're perpendicular, if you get ugly numbers. But we got nice clean numbers here once we got rid of that fraction, so we know these are perpendicular. All right, and then for the second one, we're again checking parallel, perpendicular, neither. So I'm going to go for the first one. The slope of QV, same order, is 9 minus 4.5 over 4 minus negative 2. We add, so that's 4.5 over 6. I'm going to multiply by 2 to get rid of that decimal, so we get 9/12. Dividing by 3, we get 3/4. All right, second one, the slope of RM is equal to, again, same order, negative 1.5 minus negative 12 all over 10 minus negative 4. So these all go plus plus. A lot of double negatives here to make mistakes with. So this becomes 10.5 over 14. I'm going to multiply by 2. We get 21 over 28. Dividing by 7, we get 3 over 4. So sure enough, the two slopes were the same. These two lines were parallel. Okay. Now write an equation of the line that's parallel to this and contains. So in general, the plan for writing the equation of a line is we need a slope. It tells us that it's parallel to this line. This line's already in y equals mx plus b. So the slope of this line is 8/5. I can tell because it says y equals. So I know anything that says y equals is in well, any linear, so straight line that's in y equals has the slope and the y-intercept right in front of me. Even if they look like they're missing, like y equals 3x, I know there's really a plus 0 there. Or if it's y equals 5, that's 0x plus 5. So I know the slope is given to me. It's 8/5. Mine is parallel, so there's my slope. And now I have a point, so I can just write it in point-slope formula. Point-slope formula says y minus the points y equals slope times x minus the points x. And so here I'll just write the equation on my line. Y minus -10 equals slope, 8/5, times x minus the x value, -6. Done. Equation of my line in one form is y plus 10 equals 8/5 times x plus 6. That's one way. Now I could rearrange that to get that to y equals mx plus b. So let's just do that. So if I just distribute, I'll do that on the left over here, just making some room. We get y plus 10 equals 8/5 x plus, and then 6 times that, so that's 48/5, right? Because that'd be 6 over 1, top times top, bottom times bottom to multiply fractions. And then we just subtract the 10. So y equals 8/5 x plus, and so we have 48/5 minus 10, but 10 as fifths is 50/5, right? So that's just writing 10 in terms of fifths. So what we end up getting is y equals 8/5 x minus 2/5. So either format you want it. I like just going straight to point slope because I had a point and a slope, right? Write the equation of the line that is now perpendicular to this line and contains a point. So we got to first find the slope of this line, okay? I'm going to rearrange it into y equals mx plus b. So I'm going to subtract the 3x. Okay, so off to the left, y'all do this one like in purple so it stands out a little bit. I'm going to zoom in. So I have -4y equals, I subtracted the 3x plus 9. I divide everything by -4, right? And I have to distribute that to every term. Okay, so I get y equals positive 3/4. That's negative divided by negative x minus 9/4. So the slope of this line was 3/4. Now our line is perpendicular, so our slope we were looking for is -4/3. Great, we have our slope and we have a point, so just going straight to point slope form that I mentioned up here, I can just write the equation of my line. The equation of my line is y minus the y value of -5 equals slope -4/3 times x minus the x value of my point, which is -4. So going straight to point slope form, I know my equation is y plus 5 equals -4/3 x plus 4. Or I could rearrange into the other format. So I just distribute and I go, okay, so y plus 5 equals, distributing that in, -4/3 x, and then times 4, so that'd be -16/3. And then we just minus the 5 from both sides. So now we have y equals -4/3 x, and then we just got to clean this up. So how do we combine these? Well, 5 as thirds is -16/3 minus 15 more thirds. So that's -31/3. So whichever format you wanted, both of those are valid equations of the line. Okay. Now, this next one says, a car rental company charges $30 per day plus 28 cents per mile M for each mile over 100 miles to rent a car. So for the first 100 miles, it's just $30, okay? So over 100 miles. Then it says, Mr. Benitez rented a car for 5 days. So that's, figuring that out, is $30 per day, and drove this much. Write an equation that represents the total cost, C, to rent a car for 5 days. What was Mr. Benito's total cost? So write an equation that represents the total cost. Now, this is a little tricky because there's really two separate equations here, okay? You can't, well, you could write one, but it's a little misleading. All right, so here we go. Total cost C, so C is the cost, is equal to rent a car for 5 days. So if we're renting it for 5 days, what's the base that we're being charged? Well, we're given that it's 5 days. So we're given that we're going to be charged $30 per day. So we know we're starting at a $150 charge, regardless of if we even put the key in the car at all. If we just pay them money, say I want the car for 5 days, and just leave it on their parking lot, we still pay them $150. Okay, plus we're charged 28 cents per mile times mile, but that's only for each mile over 100. So if we're going to correctly write an equation for this, we actually need two separate things. So really there's, I don't have room here to do this. I'll shrink this a little bit. Okay, so here's our equation, sort of. Okay, this is, whoops. Really the charge is just $150 if m is less than or equal to 100, right? So this is called a piecewise function. So actually, that's the charge if you drive under 100 miles, right? But if you drive over 100 miles, then you're charged 28 cents for everything over 100. So what we need to do is take m and minus 100. And so that's why, so if you drove 101 miles, you're only getting charged 28 cents for that one extra mile. So you take the number of miles, subtract the 100, and there you go. So that's our equation. What was Mr. Benitez's total cost? So since he drove over the 100 miles, this was our equation. He was charged some extra. So the cost equals 150 plus 28 cents. Whoa, that was a crazy 28 there. Let me erase that. Plus 28 cents per extra miles over 100. Now, the reason I wrote this as a piecewise function is because if you drove under 100 miles, our equation would say you were like being subtracted 28 cents for every mile under 100. That's why. So this equation only works if you drove over 100 miles. Okay, so I'm just going to change the coloring of the ones we're doing right now. Just so, let's go green. So it's a little different from the one before. So now what we need to do is just figure out how much you got charged. So we just plug in $255. So the cost is 150 plus 28 cents, 0.28, times, and then 255 minus 100 is 155. So I'm just going to pull out my calculator really quick and see what 155 times 28 cents is. 155 times 0.28, that's $43.40 is the extra charge on top of the 150. So the total he was charged is $193.40. So that's the second part to this answer. Now really, again, there's two separate equations, but we know which one we're using for Mr. Benitez specifically. So the cost was $193.40. All right, let's look at the next one. That was a cool question, some real-world linear equation. All right, given the following information, determine which lines, if any, are parallel. State the postulate theorem. So if we know that R and S, so R to N to S is this angle, is congruent to PSN, this angle. Well, those are alternate interior angles along this transversal, telling us that the sides that form the angle, this side and this side, must be going in the same direction. So that means these two lines are parallel. So that's RN is parallel to PS, or you could name it PV or SV. I'm just going to call it PS. All right, and then the next one says, well, what if instead we know that MRS, so that's this angle, plus RSN, so that's this angle. So what if those two angles add up to 180? Well, that's a 180 degree turn. That's same side interior, consecutive interior doing a 180 degree turn. That tells us that these two lines that made the 180 degree turn are going in the exact same direction. So that means that, and I'm just going to name these lines, so MR, oh, and we're supposed to say the name of the theorem. I'll do that in a second. MR is parallel to NS, okay, and this is the converse of consecutive interior angle theorem. This first one was alternate interior angle, but it was the converse. The converse is the one that says if angle relationship, then parallel. The forwards is, the original theorem was if lines are parallel, then we know angle stuff. So this is the converse of alternate interior angle theorem. Just separate those. Okay, and then 18 is find x. Oh, this is a totally separate question. Find x so that a is parallel to b. Well, the only way that a would be parallel to b, given that these two are alternate exterior angles, is the if alt exterior angles congruent, then parallel. That's the converse of alternate exterior angle theorem. So what we want to show is that 229 minus 4x is equal to 6x minus 13. That's what we want. So let's see if we can make that happen. So we add 4x to both sides. Okay, we add 13 to both sides. And we get 10x equals 230, 242. And dividing, we get x equals 24.2. So x equals 24.2. We stop there. Okay, so these next ones got crossed out, but I'm going to do them anyways because they're fun problems. All right, you can skip past these if you want. So find the distance between parallel lines. So the distance between parallel lines, I don't have a lot of room to work with here, is just like the distance from a point to a line. If we pick any point on this line, what's the distance to the other line? It's the perpendicular. So what we need to do is pick a point on one line, draw the perpendicular, see where they intersect, so we get 2 points, and then just find the distance between those 2 points. Okay, so for 19, let's see, what's a really easy point? Well, the y-intercept of this line is 2. So I'm going to pick a point on this line, which is 0, 2. That's a nice easy one, okay? So now I need to find the perpendicular line going through that one at point 0, 2. Okay, well, I picked that point because it's an easy y-intercept, so I know the equation of my perpendicular line going through that point is y equals perpendicular slope, positive 4x, plus the same y-intercept because I chose that point. So there's my line that's perpendicular to this line and passing through the same y-intercept. Okay, so now I just need to see where does that line hit this line, and then my final part is just what's the distance from that point to where it hits the other line, because I know it's perpendicular. So I say I found 0, 2, I found the equation of this line is y equals 4x plus 2. Now I just need to see where does that hit this line, right? Well, how do you check where two lines intersect? That's just a system of equations. So I have two equations. I'm going to do it down in the bottom left where I have a little room. So where does y equals 4x plus 2 intersect system of equations with y equals negative 1/4 x minus 9/4? Okay, well, let's just substitute the y equals and the y equals and get 4x plus 2 equals negative 1/4 x minus 9/4. I'm going to multiply everything by 4 so we don't have fractions. So that's 16x plus 8 equals negative x minus 9. So adding x, we get 17x on the left. Subtracting the 8, we get minus 17. So dividing, we get x equals negative 1. Now that's not the solution. We need a point. So plug negative 1 back in. We get negative 4 plus 2 is negative 2. So we should get this point here is negative 1 comma negative 2. I'm going to double check that it's on the other line. So if I plug in negative 1 into this bottom one, I get negative 1/4 times negative 1 is positive. And then minus 9/4, that gives me negative 8/4, which is negative 2. Check. That point is on both lines. That's the point where they intersect. So the last part is, what's the distance between 0, 2, and negative 1 comma negative 2? Well, I could just use this graph down here really quick. So 0, 2 is right here. Negative 1, negative 2 is right here. So that's just a right triangle. That's, whoa, that was a terrible right triangle. That's just a right triangle that's over 1 and up 1, 2, 3, 4. And so I just do distance formula. 1 squared plus 4 squared equals the distance squared. So that's 1 plus 16 equals c squared. So that's 17 equals c squared. So the distance between those lines, square root 17. Groovy. Okay, I'm going to just chop that work off so I have room to do number 20. Graph line M. I'm going to get rid of this. Graph line M, whose equation is negative 6. Okay, so I'll graph that one first. So rearranging it, I'm going to add 6x to both sides. So I get negative 3y equals positive 6x equals 9 plus 9. Okay, so all I did was move the negative 6x to the other side. Then I divide by negative 3, and I get y equals negative 2x minus 3, because I divided by negative 3. So then I'm going to graph that. So I'm going to go to negative 3, and I have a slope of negative 2. That means negative 2 over 1, or down 2, right 1, and then up 2, back 1, up 2, back 1, up 2, back 1. So there's my line. Okay, got that. And then it says, that was M, by the way, M. Then it says, construct a perpendicular line through 3, 1. So 3, 1 is 1, 2, 3, up 1. Okay, so here's 3, 1. It says perpendicular line. Well, what's the perpendicular slope? The perpendicular slope would be positive, flip it over 1/2. So we're going to go up 1 over 2, down 1, back 2, down 1, back 2, down 1, back 2, down 1, back 2. No, I didn't construct, but I algebraically solved and drew. And find the distance from P to M. So I'm finding the distance from P, 3, 1, to the line M. So that's just perpendicular straight at it. So that's just the distance between this point, negative 1, negative 1, and that point, 3, 1. And so I'm just going to use the Pythagorean theorem and say, well, I went up 2, and I went over 1, 2, 3, 4. So that's just a right triangle. That's 2 by 4. And so that's 2 squared plus 4 squared equals the distance squared. That's 4 plus 16 equals c squared. That's 20 equals c squared. So the distance is root 20, or we simplify, and we get that's root 4 times root 5, or, whoops, 2 root 5. So up here I'm going to write both. So that's square root of 20, which is equal to 2 root 5, which is approximately equal to, and you could punch in a calculator, and I don't know, 4.4, 4.5, something like that. Okay, last one. Suppose line P is perpendicular to line S, and line Q is perpendicular to line S. Okay, so you've got a line S, and you've got two lines perpendicular to it, okay? So you've got P is perpendicular to it, and Q is perpendicular to it. Are lines P and Q parallel under all circumstances? Oh, snap-a-doodle. The answer is no. 3D. Oh, and this is going to be hard to draw, but let's do it. Okay, so here's a plane, right? So on this plane, you have line S, and you have line on this plane, line P. Okay, that's P. And then you have, and that's a right angle there. Okay, but then you have one that's non-coplanar with those that passes through S. So this one is passing straight through like this. It still forms a right angle, and then goes down like this. But those are not parallel. So if 2D only, or AKA all three lines coplanar, then yes. Right? But if we're talking about 3D space, no, it's totally possible to cross through a line forming a right angle, but rotate, right? Like rotate this one in 3D space around line S, like you're turning it like a knob, and have it point that direction, or this direction, or this direction, or this direction, where it still forms a 90-degree angle with S, but you can spin it in 3 dimensions. And so it doesn't have to be this direction parallel to PS, or to S, perpendicular to S and parallel P, I could rotate it in 3D space. That's a very cool question. I like that one. All right, let's do one or two more, and I got pause and get back to Zoom. Okay, let's see. If triangle ABC is isosceles, angle B is the vertex angle. Okay, so that's good. So we got ABC. B is the vertex angle, which means these are the legs. The vertex angle is between the congruent legs. AB is 20x minus 2. BC is 12x plus 30. And AC is 25x. Find x and the measure of each side. Okay, let's do it. So the two sides that we know are the same are AB and BC. So we know that 20x minus 2 is equal to 12x plus 30. And then we just solved that. That was our relationship we could solve. So subtracting the x, we get 8x equals, add the 2 to both sides, 32. So x is 4. Then we just plug it in, and we get the three sides are, hopefully it works out that they're equal, right? We get 80 minus 2 is 78. On the bottom, we get 48 plus 30 is 78. That's good. And the last side is 4 times 25, or 100. So the three sides are 78, 78, and 100. Okay, given 3 points, find the measure of the sides of the triangle, then classify it by its sides. Okay, so we just used the distance formula 3 times, but maybe there's a more elegant way. So 0, 4, 5, 4, 5, 4, same height. Ooh, that's nice. We went from 0, 4 to 5, 4, so that's just 5 over. It was a horizontal line. And then we go to -3, -2 down here. Okay, so we know one side's 5. That's nice. So we need to find all three, so we found one's 5. Now, this one, from 0, 4, back to -3, -2, what did we do? And then I'll put 5, 4 here. So I'm just going to make right triangles rather than distance formula. So what we did is we went back from 0 to -3. That's back 3. And then we went down from a height of 4 to a height of -2. That's down 6. Okay, so one is a right triangle that's 3 by 6. And then the other one, we went over from -3 to 5. So that's 3 plus 5 is 8 across. And then we went the same height from -2 up to 4 is 6. So the other one is a 6 by 8. Okay, let's do those distance formulas really quick. We get 3 squared plus 6 squared is the distance squared. That's 9 plus 36 equals c squared. That's 45 equals c squared. So the distance is root 45, or if we simplify that to be root 9 root 5, that's 3 root 5. And then the other one is 36 plus 64 equals c squared, or 100 equals c squared, or c is 10. That was really just a 3, 4, 5 triangle doubled. We get really used to those 3, 4, 5 triangles. So we had a 5, a 3 root 5, and a 10. And so it says classify the sides by its sides and by its angles, okay? Well, by its sides, we know it's scalene. Now, do we know anything about its angles? Now, we don't have like trigonometry yet to actually solve for angles, but what we do know is a horizontal line and a vertical line form a right angle. And look, we did more than that. Instead of going straight down from that horizontal, we went down and left. That was more than a right angle. So for sure we know it's obtuse just from the graph, and our knowledge of perpendicular is 90, and that was more than, right? It was 90 plus some. So it was scalene obtuse triangle. This is by sides, and this is by angles. Okay, I'm gonna pause and go to Zoom, and then I'll time travel and come right back and keep working. Okay, I'm back. So here's the problem we're looking at. We got either triangle sum here adds to 180, or we got exterior angle theorem here that these two add up to be equal to this. So this is measure of angle 1 plus measure of angle 2. Or we got linear pair adds up to 180. So we got all sorts of things we could do here. So it says find x. So to find x, the relationship is they add up to 180. So 3x minus 10 equals 8x minus 30. So subtracting the 3x, adding the 30, we get x is 4. Okay, so let's plug it back in and make sure it works. We have 32 minus 30. Woo, a 2-degree angle. That's crazy. Did I do something wrong? Oh my gosh, I did do something wrong. I was moving too fast. That was not correct. These add up to be equal to 180. Good thing I plugged it in. We all make mistakes. We are all human. Okay, 11x minus 40 equals 180. We add the 40, we get 11x equals 220. We divide by 11, we get x is 20. Now let's plug it in. This is 160 minus 30. That's more like the picture, 130. Plug it in 20 over here, we get 60 minus 10. That's a 50. Check. It works. Okay, so x is 20. Then it says find measure of angle 1 if it's in this expression. Well, x is 20, so that's just 80 plus 10, or 90. Okay, so that's 90 degrees. Oh, we got a right angle here. And if that's 90 and the other's 50, we could just go ahead and subtract from 180 and get that this is 40. And sure enough, that was the next question, is find measure of angle 2. Okay, verify that the following preserves congruence. Assuming the corresponding angles are congruent, triangle ABC is reflected over the x-axis. So we've got this picture here of -1, 1, so that's A. We got B is 4, 2, and C is 1, 5. So here's A, B, C. And to show that it's still congruent when we reflect it over the x-axis, so here's the x-axis, reflecting it over means like a mirror image, or like flipping it. Like imagine we have the whole plane and we swing it like 3-dimensionally in a circle around the x-axis. So what we end up getting is A, C, B, and it tells us that, or we do primes to show that it's the image of, so we know which are which, but we're not literally labeling them as A because A already has a location in space. And so all we're trying to do, if it says that the corresponding angles are congruent, is just show that all the sides are congruent. And so down here, I'm going to say, okay, well, really they're saying use the distance formula. And so from -1, 1 to go up to C, that's going from 1 up to 5, which is up 4. And then we're going over from -1 to 1, so that's 2. And then down here, we're going from, and again, now I'm using these points, so we're going from -1 down to -5, that's 4. And we're going over from -1 to 1, that's 2. Well, by SAS, these are congruent, so by CBCTC, these match. Okay, I'm going to do the same thing on the others. So to get from C to B, we're going from an x value of 1 to 4, so that's over 3. And we're going from a y value of 5 to a y value of 2, that's 3. Okay, and then to get from C prime to B prime, we're going from a y value of -2 to a y value of -5, that's down 3. And then we're going backwards in the x value, so we're going from a 4 to a 1, that's 3. And sure enough, by SAS, this triangle is congruent to this triangle. So by CPCTC, their hypotenuse matches. And then same thing, I'm going to do the A to B. So A to B, we went over from A to B, -1 to 4 is over 5. And then we went up from a y value of 1 to a y value of 2, so that's up 1. We have a right angle. And then over here, we went same thing. We went from -1 to 4, so that was a total of 5. And then we went from a y value of -1 to -2, so that's a 1. So by SAS, congruent to this, CPCTC, these match. Okay, woo, that's a cool little like proof verifying there. Or you could have found all the lengths. So the length of this side, Pythagorean Theorem, you get 3√2 after you simplify. You could do that for every single side. I liked using some triangles are congruent in CPCTC. Okay. Determine whether these two triangles are congruent given the side. So the only thing we could do here, since we don't have any angles, keeping in mind we actually could find right angles by perpendicular, but let's say we have no angles. Really, we're just trying to find the triangles are congruent by SAS. So I'm going to graph the two triangles separately so my pictures aren't all messy. So for the first one, I've got 1, 2, and 5, 4, so 5, 4. And 3, 6. Okay, so here's 5, 4. Here's 3, 6. And here's 1, 2. All right, and then over on the right one, I'm going to do -4, -5, and 0, -3, and -2, -1. So here's 0, -3, -2, -1, and -4, -5. So I'm going to do the same thing as the last one and just use CPCTC with congruent triangles. So here I'm going up 2 and over 2. Okay, that's right triangle. Now I could use Pythagorean Theorem there. 2 squared plus 2 squared equals c squared. I get 4 plus 4 or 8. And so I get this is √8, right? And then I could do the same thing in the other triangle. In this one right here, I went over 2 and down 2, so I get this is square root of 8 by the same Pythagorean theorem. Then I'm going to do a different color. this side over here? Well, this side is up 4 from 2 to 6 and over 2. And so that's 2 squared plus 4 squared equals c squared. That's 4 plus 16 equals c squared. That's square root of 20 is c. Now, you could simplify both the square root of 8 and the square root of 20. Now, over here, let's see if one of those other sides is over 2 and up 4. So let's see. Well, this one is down 2 and over 4. Well, sure enough, look at that. So that means this one is root 20. Okay, two sides are the same. Hoping for 3. Let's try it. So third side here, we went down 2 and we went over 4. Oh my gosh, we already did that arithmetic. That's a square root of 20. Sweet. Let's do this one. That is over x value 2 and down from -1 to -5, 4. And oh, we already did that math. That's square root of 20. So these are two isosceles triangles. They both have all the same length. So yeah, these are congruent by SSS triangle congruence. Okay, and yeah. All right, let's look at 8. In the figure below, we know that AC is congruent to FD. We know that AB is parallel. That's already drawn on there. And AC is parallel to FD. I'm going to use 2 marks, okay? Name the postulate that could be used to prove that these two triangles are congruent. Choose from SSS. Okay, so if we have these two lines are parallel, we have this transversal creating this angle and this angle as alternate interior angles being congruent. Okay, similarly, if we have, I'm going to do a different color, if we have these two lines are parallel, then we have this transversal creating two alternate interior angles. And so alternate interior angle theorem says these two angles are congruent. And so now what we have is two congruent angles, and then is the side between them? So we have angle and angle. Do we have this side? No. We have a side that's not between them. And then we have two angles in the other one. And sure enough, same side is congruent adjacent to the double angle marking. And so yeah, for sure, we know these are congruent, and that's by AAS triangle congruence theorem. Cool. All right, then for this one, complete this 2-column proof. So we know that ABC is isosceles with base AC, so that tells us these are the two congruent ones. We know D is the midpoint of the base. So really quickly, the definition of midpoint is going to give us this. All right, and then we want to prove that BD bisects ABC. So we want to prove that angle 1 and angle 2 are the same. So that's going to be our last step. And then we use the definition of a bisector to get to there. Okay, so we know that AB is congruent to CB. That's by the definition of isosceles triangles. Then that tells us that the base angles are congruent. You could say that that's the base angle biconditional as I say it, or correctly it's the base angle theorem. I'd also be okay with the biconditional, which covers the forwards and the backwards, so either wording there. And then D is the midpoints given. So then we know now they use midpoint theorem. I just call that the definition of a midpoint. I think that's the definition of a midpoint, whether it's being equal or congruent. It's cutting it into two equal or congruent parts. So now we know that the two triangles are congruent by what? Well, I don't like that they left a step out here. Oh, they didn't leave a step out. They established these are congruent. Got it. I would have just, once you had those sides are congruent, you could have just said SSS because reflexive property. I thought that's what they were going for here. But they established these two angles are the same, and these two sides are the same, and these sides are the same. So by their steps given, the only possible way to say that the triangles are congruent was by two sides and an angle between. So it has to be SAS triangle congruence. Now, could you have used something else? Yes, but you would have had to add more steps before this. Okay. And then we know the triangles are congruent. So CP, CTC, these angles are the same. And then definition of bisector. Great. Okay, find X. Well, you could say all of these add up to 180. Done, find x. But even easier, it says it's equilateral, so let's just choose one, like for example the 15x plus 15, and that must be equal to 60 degrees, because every equilateral triangle has 60-degree angles. That means 15x plus 15 equals, and we subtract the 15 is 45. Dividing, we get x is 3. Let's just double check that that works though. So that's 45 plus 15 is 60. That's 51 plus 9 is 60. That's 63 minus 3 is 60. Good job, us. It worked. Position and label isosceles triangle ABC with base AB. Okay, so we got triangle ABC. So the base is AB. You don't have to label on the bottom, but you do know these are congruent. Okay, and this is C. And it says label it on the coordinate plane. I mean, sure, okay. So let's do it. Position, triangle ABC. So the easiest thing is to put a point like A at the origin and then lie the first side along here. So let's put B here. So then this has to be, if this is 0, 0, and AB is this long, well then this has to be A plus B long, comma 0, right? Well, then where's the vertex? Well, the vertex has to be on the perpendicular bisector. It's actually the perpendicular bisector theorem that the perpendicular bisector is every point that is equally distanced from A and B. So we don't know where the vertex C is. It never mentions anything. So let's just put a C up here. What we do know, though, is that its x value is half of that other value, right? We went halfway across. So C is A plus B over 2. And then comma, we don't know the value, so let's just add a new variable, C, for the y. And the y could be anything. I mean, it can't be 0. I guess you should write that off to the side. C can't be 0. But other than that, it could be any value. Very cool. Okay, so that was our triangle, and those are the points. All right, in the bonus, in the figure, ABC is isosceles. ADC is equilateral, and AEC is isosceles. Oh, that's cool. So these are isosceles. This one's equilateral with this one, and then this is 3 dashes, 3 dashes. So it's saying the measures of those are all equal. So 9, 1, and 3. So 9 is the same as 1 is the same as 3. Well, 3 is the same as 4, okay? And now could we say 1 and 6 are the same? Like by symmetry, you want to say it, but should we? Could we say it? That's a good question. Well, let's do it this way, okay? You know this is 60 degrees here. So 60 plus 1 is the same as 60 plus 6. So yeah, then this one is going to be the same as 1, is the same as 3, is the same as 4. And we know that those are 60 degrees, and the measure of angle 8 is 60 degrees. Okay, so what could we do then? How can we find this? Let's find the measure of the 9 numbered angles. Well, look at this. We know this whole triangle is 180, and look at what we have. Here we have, this is the measure of angle 9. This is 60 plus the measure of angle 1. But up here it says all those are the same, right? So let's just call this x. So we got x, 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 x. And so what we've really got is 60 plus x. And here we've got 60 plus x. And so total, those all add up. Oh, and this was an x. So total, those all add up to 180. So what you've got is 60 plus x plus 60 plus x plus x is a total of 180. So that means we got 120 plus 3x equals 180, or 3x equals 60, or x equals 20. And so plugging that back in, let's see what we get here. So we get this is, oh, and let's erase this one too. We got 20 degrees. And again, 9, 1, and so this is 20, this is 20, this is 20, okay, and this is 20. Well, let's find the other angles. Well, we already knew this was 60 because it's equilateral. So 60 minus 20, this is 40. We knew this was 60. Over here, we get, again, 60 minus 20. So this is 40 degrees. The only one we don't have is 70. And that one's in a triangle with 20 and 20. And so we just do 180 minus 20 and 20. That's 180 minus 40. And so we get 140 degrees for 7. So you could write those all out. But basically, there's only 4 angle measures. So measure of angle 7 is 140 degrees. Measure of angle, next one is measure of angle 8 is 60 degrees. And then measure of angle 2 is the same as measure of angle 5 is 40 degrees. And then all the rest are 20 degrees. So angle 1, angle 6, angle 3, angle 4, angle 9 are all equal to 20 degrees. And those are all measure, putting an M before them. All right. Oh, that's where chapter 4 ends. So let's stop this video and I'll make another one.